Objective of this video is to discuss strength of the concrete, modulus of elasticity of the concrete, shrinkage of the concrete, and creep. So 4 topics will be covered. Now first talk about the strength. When we talk about the concrete, there are 2 kinds of strength. One is compressive strength, another one is tensile strength. Let's talk about the compressive strength first. Now when you are taking the columns of the concrete, generally it's subjected to the compression load, and concrete is very good in compressions. It has a very good strength in compression and generally used to carry the compression load. On the other hand, concrete is not good with the tensile load. If you're taking the beam and if you load the beam on a transverse loading, the top flange subject to a compression, bottom flange subject to a tension, and it's not good with tension. So therefore we put the reinforcement to prevent the crack, and the concrete generally cracks under the tensions. Now it's not good in tensions that we're going to look at numerically soon. Now table 3 point. Now we look at this compression tension. Now how we know the values for those compressive and tensile strength? So Australian standard 3600 on page number 42, page 445, table 3.1.2 gives the concrete properties. Now it's given at 28 days. Now I can show you where this table is. Now that table is given on the page number 45 on AS3600 2018. We have a table 3.1. It has this characteristic strength of concrete at 20 megapascal, 25 megapascals, and so on up to 100 megapascal. So that is the compressive strength, which is called characteristic strength of the concrete. That is FCDS. Now when we talk about the tensile strength, that is represented by FCT-F, and that has an equations that is given on the page before, which is on page number 44. On page number 44, it has an equation to calculate FCT-F is equal to 0.6 square root FCDS. That's what I written here, and that is known as characteristic flexure tensile strength of the concrete. So you can see that this tensile strength is very small. So if you substitute this FC value, let's say it has a 20 megapascals strength, then in that case we have to have 0.6 times square root 20 megapascal. So it is very small tensile strength in this numerically can present here, and this FCT dash also can be found as 0.36 FC dash at 28 days and standard time. Now that's the about strength. Now let's talk about modulus of elasticity. Now the modulus of elasticity generally represent the stiffness of the materials. Two materials, if you draw the stress strain curves, concrete has a less elastic modulus. So if you take the slope of the initial portion of the concrete stress strain curves, you can find this stress. You can find this modulus of elasticity is generally rise over run. So stress divided by strain value. So if you are taking this stress value here divided by strain value here, it gives you this ratio give you the modulus of elasticity. Same thing for steels. Now steels behave linearly in the initial portion, so it's quite easy to find the elastic modulus, unlike concrete. This is non-linear behavior. So it's a non-linear stress strain curves. Because of this non-linear stress strain curves, this is due to the material strength and the stress experiencing by the concrete. Now where we can find this modulus of elasticity of the concrete? Again, we can use table 3.1 that gives us the modulus of elasticity. Same table that we use for finding the FCDS on page number 45. We can find modulus of elasticity EC. It has a different value for different concrete strengths. Now let's talk about the shrinkage, number 3. Now shrinkage has a 2 kind. It has given in the clause 3.1.7 on page number 46. On page number 46, it has a whole page talking about calculating the shrinkage strain, and it's on the page number 46. Shrinkage has 2 types. One is autogeneous chemical shrinkage and another one is a drying shrinkage. Now these 2 different names are going to explain here. Now autogeneous is also known as a chemical shrinkage. Now it is a chemical process. What is the chemical process? Meaning that if I take these cement particles in the concrete, these cement particles dried out due to the heating. So that cement particles are drying out. That is the chemical process that is shown here. So it's generally the chemical process and it's a hydration of cement particles. On the other hand, drying shrinkage is just losing the water particle from the concretes. It's not the chemical process, but just drying out due to the heat of or temperature. This water particle drying out. What is the effect of shrinkage? This shrinkage will deform the concrete at some amount, so that will reduce the length of the cross sections of the members that is made from concrete. Now it has a design shrinkage strength. It's represented by epsilon CS, is nothing but the summation of autogeneous shrinkage strength, which is C epsilon CSE, plus drying shrinkage strength, which is epsilon CSD. That is given in the clause 3.1.7.2. That's equation is given here. 3.1.7.2. That's the design shrinkage strength, autogeneous shrinkage strength, and drying shrinkage strength. Now, if I represent graphically time versus strength, and the few days or few weeks, it has a very fast chemical process occurs, and that is autogeneous shrinkage, that is represented by this blue line. And very slow process, you can say that this one, and then it's significantly deform that strain, that is due to drying shrinkage. And if you add them together, it can get the drying shrinkage. That's just representing these equations. So that is about shrinkage. And now talk about creep. Creep has only two words that you need to consider. Is generally the constant load. If you're considering the dead load generally the constant load over the period, so over the time. So when you're asking the definition of the shrinkage, two important words is the constant load. For example, dead load generally apply the constant over the life of the members. So let's say if I take the concrete members and apply the constant load, that constant load over the period deform the concrete members. So that is deformations. Now you can see the difference between the creep and shrinkage. Both are under this shrinkage it's also deformed, but this is the chemical process and drying out process. On the other hand, this one has nothing to do in the shrinkage. There is nothing to do with the loading, so there is loading does not come into pictures. But in the creep, it has no any chemical process, nothing else, but this due to the load and time, it has this deformation. So shrinkage both has a time. Shrinkage has a chemical process like heating process and the drying out process, and it's over the time again, and it's deform the specimen. Here is the deformation, but over the time due to the constant load. And that's the 4 concept. Thank you very much.